Martin Kosic here. Today I'll be teaching you a lesson on chain rule. Before we get into that, I'd like to do a quick review on power rule and taking the derivatives of functions. So first we'll get our f of x here. And we'll just do a simple one for now, something like 4x squared plus 9. F prime of x right here. Okay, and so we need to bring the 2 down and multiply with the 4 to get an 8. X, and our power will be always n minus 1. So 2 minus 1 will be 1, so we don't need to write that. And because 9 is a constant, it has no derivative, and therefore we can disregard it. Another one we can do here, we'll write our f of x equal to, I'll try something interesting, 16x to the power of 4 plus 9x cubed plus 10x. So a little more involved here, but definitely not too difficult. So our f prime of x. 16 times 4 is 64. Because we bring that 4 down, so we have a 64 here. X n minus 1, 4 minus 1 gives us a power of 3, plus 9 times 3 is 27, right here, right? 9 times 3. And then n minus 1, 3 minus 1 will give us a power of 2, plus 10 times 1 gives us 10, and 1 minus 1 gives us 0, so our x will disappear, and we'll just have a constant here left over. Excellent. So now that we've done that, I think we're all pretty comfortable doing this. I mean, it's a prior lesson. We all know our product rule and our power rule and our quotient rule. So now it is time to learn chain rule. This is a very fundamental rule. It's very important in taking the derivatives of more complex functions, which you're about to see. So a chain rule involves a composite function. Just write that down for you here, composite function. Okay. And I'll just define that for you in words here. So a composite function is a function whose values are found from applying one function to the result of another, usually seen in the form f of x. I mean, people use different variables, but for our purposes, f of x equal to g of h of x. Reason it's called composite is because it's two functions, so whose values are found from applying one function to the result of another. So, I mean, we have a function within a function here, and this is our composite function. And to take the prime of this, using these generic terms, we do something like this. So the derivative, or f prime, would be g prime of h of x multiplied by h prime of x. So the prime of the outer term, without touching the inner term, multiplied by the prime of the inner term over there. So I hope y'all can all see that clearly there. Okay, so now that we've defined a composite function and we've explored our general terms, we can move on and begin using some examples to learn chain rule. Just focus that for you there. Okay, excellent. Okay, so moving forward, we will start with a simple function, a linear function within a power function. So the first composite function we'll be dealing with here is our f of x equal to bracket 4x plus 9 cubed. Right? Pretty simple, nice to look at, nothing too scary there. So first, and we always know, so our f of x here, and we always know that our composite function will be in the form f of x is equal to g of h of x. So it's important now to identify our g of x and our h of x. So it's very easy. First, it's very easy to see what our h of x is, which is our inner term here. So we can call our h of x 4x plus 9. Oh, yeah, 9 there, sorry. And our g of x will be these two outer brackets and this cube here. So our g of x will be and this x being this inner term. We can also define this. We can also relabel our g of x correctly by saying f of x is equal to h of x inside to the power of 3. So this way we can show our g of x in 3 ways. This x, one can think of as the inner term, h of x, One must just think of it like that. We can't correctly write h of x in there. But here we can call f of x this. And here we just see our h of x and our g of x on the outside. So we know that we need to take the prime of the outside and then multiply it by the prime of the inside. So let's write our f of x here again. 4x plus 9 to the power of 3. So our f prime of x, quite simple. So we bring our 3 down just like normal. We completely forget about the inside for the first bit of this. So we bring our 3 down just like normal, 3. And then our h of x remains unchanged inside, 4x plus 9. N minus 1 as per usual. And we end up with a square out here. So we've completed our first term. We've taken the prime of that g of x first term. And now we're multiplying it by the inner term, the prime of this inner term, the derivative of this inner term. So our h prime of x here, in this case, will just be 4. Because we'll take an n minus 1 from here. 1 minus 1 will be 0, and the 4 will remain. And because 9 is a constant, the derivative is equal to, the derivative of a constant is, we can disregard 9 because it is a constant and the derivative has no slope. Okay, there we go. Sorry about that. And a good way to simplify our derivative here is multiplying this 3 and 4. Easy enough. If you have a simple number out here, we can just multiply them to make them into one clean term. So we'll create 12 times 4x plus 9 squared here. Excellent. So that's quite easy. It's nothing too much, as provided you break it down and you keep thinking of it in terms of the generic term and just, staying organized and staying on top of it. So another example, another crucial type of chain rule that you'll run into frequently is that using a square root. So our f of x here will be square root of 3x squared minus 1. Right? So before we begin applying chain rule to this, it's very important to note that this is actually a power function. Well, this is a composite function. There's a quadratic on the inside and there's a power on the outside, because this can be transformed into, we can also call our f of x 3x squared minus 1 to the power of 1/2. This is important to note because this really makes our chain rule a lot easier to apply once we can visualize the function in this manner. So now we remember our f of x is equal to our g of h of x. Define our h of x. We see it right here on the inside, so we know it is 3x squared minus 1. And we can define, I'm not going to just define our g of x because I feel like that was somewhat unclear. But we can call our f of x h of x to the power of 1/2. And it's very clear now what our g of x is because we can just see this. And if we just forget about the inside there, we see these two brackets and the power of 1/2, which allows us to visualize that well. So we'll restate our function. F of x is equal to 3x squared minus 1 to the power of 1/2. Our derivative here, f prime of x, we bring this 1/2 down. Do not touch the inside like before. That h of x remains unchanged in the first term. It becomes negative 1/2 here. And there we've completed our first bit. Multiplied by the derivative of the inside. So we bring this 2 down here. And we get 6x n minus 1. So 2 minus 1 will give us a power of 1 there. And we forget about the 1 because it is a constant. So there we go. Nice and easy. And just like we did before, we can multiply this term by the term at the front there. Because it's pretty simple. It's not multiple terms. So it's not hard to multiply by 1/2. So we can end up calling this term 3x squared minus 1 to the power of negative 1/2. Awesome. So that really simplifies it there. And this kind of term may be able to be simplified further. I will introduce product rule into this later on, but I don't think we're ready for that yet. So I think we can move on to, I hope you saw that there. So just to run through that last bit again, the camera may have cut that off slightly. So our f prime of x here is this 1/2, which we brought down here, n minus 1. So 1/2 minus 1 is negative 1/2. and then we have our h of x in here that remains untouched, multiplied by 6x, which is the derivative of this h of x that we see in here. So 2 times 3x n minus 1, and we forget about the 1. And then what we did is we multiplied that by 1/2 to give us 3x on the outside and this one term at the end. Awesome. Okay, so let's do one more example. This one's a longer one, a little bit more complex. This is where it's actually, in questions like these, when you have a very large involved inner term, it may actually be advantageous to take the derivative of your h of x separately from the rest of the equation. So not to do it on the fly, but to actually have it waiting for you at the beginning. So we can see the function f of x. So this is quite long and involved. X cubed minus 4x squared plus 3x plus 2 to the power of 6. Oh, 6. Okay, so that is a long, quite involved function. We've got a pretty, I mean, it's not difficult, but we have a pretty long h of x in there. So here we go. So first we need to remember that our f of x is equal to g of h of x. Now, if you don't feel this is necessary to write every time, by all means, you don't need to. I'm just writing it for the purposes of this lesson to continue to really reinforce that this is the structure of the composite function, and to really make it clear that this is the form we're following. So moving forward, we can define our h of x here quite easily. We see it right there. Right, there we go. And when I started learning chain rule, I liked to take the derivative of my h of x and just have it sitting and waiting for me there. So what we can do here, because we have a long one and it's not, and you may make mistakes on the fly, what I like to do is just take the derivative right here. So I'll write my h prime of x, and I only really do this for these longer ones when I was learning the chain rule. So you may find it helpful, you may not, but for the purposes of this lesson, we will be doing it. So quite easy. We would just bring the 3 down here. X squared minus 2 times 4 gives us 8, and minus 1 gives us just an x here. 3 times 1 will give us plus 3, x and minus 1 will give us no x there, and we forget about this too because it's a constant. So there we have our h prime of x. This term's here, and this term's sitting and waiting for us. So we can plug that right into our chain rule once we're ready to do that. And we'll identify our g of x by writing f of x is equal to h of x, right here. And you know, we know our inner term, we don't even think about that. The power of 6. So we can just see our g clearly outlined. That's the function that acts first. So now we'll restate our f of x quite simply here. X cubed minus 4x squared plus 3x plus 2 to the power of 6. Now, just like before, we'll write our f prime of x here. We're taking the derivative now. 6 comes down, right? And then we have our h of x in here. X cubed minus 4x squared plus 3x plus 2. There's your h of x function unchanged, as always. Power of 5 up top. I don't have much space in this line, so I'll write it here. And now instead of having to look at this and all my other thoughts on this page, I can just go directly right here. And I see my h prime of x, and I can just copy that right into the function. So now we'll have our 3x squared minus 8x plus 3. Excellent. So now we have 2 terms here. And yes, this is the execution of the chain rule right there. And so in this case, it's not really possible. I mean, we can do it, but it's kind of annoying, and it won't give us one nice simple term to multiply out the 6 with this. Awesome. So yeah, that's how we're looking so far right there. And I think after all these examples, it might be time to incorporate product rule into our lesson here. So now time for chain rule with product rule. Let me just refocus that for you. Okay. Chain plus product. Wow, exciting, right? Okay, awesome. So let's do a quick review on product rule, just so our minds are fresh on that. So we know our, so we call our f of x is equal to a times b, right? We know our derivative, f prime of x, will equal a prime b plus b prime a. Quite easy. So we have something like, oh geez, that's very legible. Here, f of x is equal to like 4x times 5x squared, right? So we know we can identify our a to equal 4x, and we can identify our a prime to equal 4, and we can identify our b to equal 5x squared, and we can identify our b prime to equal 10x, right? And we can take our derivative right here. A prime b, so we find our 4 times b. So this will be 4 times 5x squared. So this will be 20x squared, right? A prime b, 4 times 5x squared, plus b prime, which will be 10x times a. So 10 times 4x will also be 20x squared. Would you look at that? Oh, no, sorry, that's very incorrect, this last calculation. So this will be 20x squared plus, sorry, I shouldn't, see, this is how I make mistakes when I go on the fly. 4x times 10x, and this will give us 20x squared. I'll check that first thing for you there. Yeah, no, that's correct. 20x plus 40x squared to give us 60x squared. So that's a quick review of product rule for you there. And now let's incorporate our chain rule into it. So my biggest piece of advice when doing product and chain rule together is to really maintain a high level of organization. Because if you start writing mistakes if you start writing things willy-nilly and have a lot of stuff written everywhere, it's very easy to slip up and put an incorrect term in. And I find that labeling my A and B really does help me stay organized and on top of the question that I'm doing. So, okay, so the function that we will be taking the derivative of here will be 4x times x plus 1 squared. So we can see the chain rule right here. This is where our chain rule is needed, and our product rule is this whole function. So we've got this multiplied by this. Right on. So first things first, just like we did before, we need to identify our A and our B. And just like I did before, what I like to do is just take the prime of each, which involves a little bit of chain rule. So we can just draw a line here. And just to see, this is what I mean by maintaining organization. I like to separate my side calculations from the main thing itself. So we can identify our A as 4x right here. And we know our A prime to be just 4, right? And we can identify our B function to be x plus 1 squared. Now the chain rule comes in. So B prime will be the derivative of B here. Will be 2 times our h of x right here. X plus 1. Multiplied by the the derivative of the inner function, which in this case is just 1, luckily for us. So this is quite simple. We don't need to worry about two terms and creating a lot of brackets. So we can multiply the 1 in here to and we'll relabel our b prime as 2x plus 1. Right on. So now we can start writing our f prime of x. So just like we did before, we need to write our a prime b. So we know it'll be a prime b plus b prime a, right? But first we have if our f of x is equal to ab, right? Just like that, I guess. Right on. And we know our f of x to be this, so we'll restate our f of x. Right? Restate the f of x there. And our f prime of x, or the derivative here, is going to equal a prime, which we have right here, 4, times b, which will be 4 times x plus 1 squared, right? Plus, there's our first term, a prime b, plus b prime a. So we're going to have 2x plus 1 times 4x. Now, a lot of simplification possible here. In all honesty, it's even possible to open this up because it's only a square and to completely expand. Some teachers ask for it, some teachers don't. I'm sure you guys are competent at that, so I do not feel the need to display that. So here we're just gonna write 4x plus 1 squared plus 4x times 2 will give us 8x x plus 1. And I mean, we can factor in x plus 1, but I think it's a little redundant here. So thank you for listening to my lesson on chain rule. My name is Martin Kosic again. Yeah, so major keys are to stay organized and just maintain a good workflow. Thank you for listening to my lesson. Bye.